Hey, grade 10s. So if I was to ask you what this is, you would tell me this is a dozen of roses. Okay. This is a dozen of rubber duckies. I'm going to go back one. We all know this is a dozen of donuts. How could you not? A dozen of golf balls. A family of 12, aka a dozen of Pepsi cans, and a dozen of eggs. Okay, so where does this lead us? It leads us to the mole, but not actually the mole, not the animal, as weird of a creature as they are. This leads us to a term that we use in chemistry called the mole. Okay, so what the mole is, and this is nothing to write down quite yet, the mole is honestly just a simple number like a dozen. Okay, we know a dozen is 12. We know a pair is 2. Those are just common numbers we use. So in chemistry, we use the common number of 1 mole. And 1 mole is actually 6.02 times 10 to the 23. That's what the number is. But it's so crazy large of a number. We don't really use it for anything other than in chemistry. But you could have a mole of anything. Okay, so you could have 1 mole of donuts, but the number of them would be so ridiculous, it's not a practical number to use. Okay, so we prefer to use smaller numbers when we do our math and our problem solving with regards to chem. Okay, so the one thing you need to know, okay, is that 1 mole of each element is actually represented on your periodic table. Okay, and we haven't used it a lot. It's been a little while since we've used it, but there's this crazy thing called your atomic mass on your periodic table. And if you remember where it is, it's in your top right-hand corner. Okay, so that right there would be something important to write down. Okay, and the other thing from the last slide, which is 1 mole. And yes, I'm only going to put an L here, not an E. It's essentially the unit for mole. Why they don't include the E, I didn't make the units. They just don't, okay? So 1 mole is equal to 6.02. There's a couple more decimals after that, but we're only going to go to this decimal, times 10 to the power of 23. Okay, so those two things are important to write down. So saying that, how are we going to actually use this? What's the relevance? We are going to be able to calculate how many moles there are of a compound in order to calculate the molar mass of a compound. And the molar mass of a compound comes into play, believe it or not just in chemistry, but in physics, we end up using it. And it is a concept that we carry through majorly into Chem 20 and Chem 30. So this is an important little lesson. So if I was to ask you how many grams there are in 3 moles of H2SO4, so we should identify this as sulfuric acid. But basically what it is, if I wanted to calculate 1 mole of this guy, I would go about it like so. So in sulfuric acid, I would notice that there is hydrogen. But believe it or not, there's actually 2 hydrogens. There is 1 sulfur, and there are 4 oxygens. Okay? So how many grams are there in there? Well, if I was to look up the molar mass of 1 hydrogen on my periodic table, I should find it to be 1.01. Okay? So in sulfuric acid, there would be 2.02 grams per mole in that sulfuric acid. Sulfur, the atomic mass, should be 32.07. Because there is only 1 of them, I don't have to do any fancy multiplication. This is just 32.07. Okay. And there are 4 oxygens, and the molar mass, or the atomic mass for oxygen is 16.00. Now, I do not get to round these. These are, use all your decimals. It's not like when you're calculating neutrons that you just get to round up or round down. No, not happening. Okay, significant digits become a big important piece to our chemistry and our physics understanding, and we'll get into that more when we hit our physics unit. So, saying that, this should be 64.00. And for a total of, I'm going to put this on top because I'm running out of room on my bottom, 98, I'm just going to add those all up, 0.09 grams in 1 mole. Okay. If I need 3 moles of them, I'm strictly going to, and very easily, multiply by 3. So if I multiply this whole thing by 3, I should get 294.27 grams in 3 moles of sulfuric acid. All right, so using molar mass. So this would be a little bit of information maybe to write down. So the molar mass can be used to find how many particles of compound you have or need. We're going to use it in regards to how much would you need for a chemical reaction. And this is going to, like I said, continue on into something called stoic when you get into Chem 20 and Chem 30. Okay? So when I say calculate molar mass of something, what I'm going to tell you to do is use your atomic masses of each element and tell me how many there are of each element, multiply, add it all up for your total molar mass. So what does this look like? What did I just say? So if I was to look at water, I wanted to find my molar mass. This is what I will ask of you. Okay? I would identify how many there are of each element in the compound. So there's 2 hydrogens, there's 1 oxygen. Then I'm going to find my atomic mass on my periodic table, and hydrogen is 1.01, and oxygen is 16.00. I would multiply. 2 times 1.01 is 2.02. I don't have any multiplication to do because I'm just multiplying by 1 here, for a total of 18.02 grams per mole. That, my friends, is the molar mass of water. And this is a common one to the point where people usually end up memorizing it just because we use it so much, especially when it comes to physics calculations with heat capacity. Okay. So if we're to do this with another element, or compound, sorry, I'm going to look at potassium permanganate. The formula is already wrote for me. The formula is balanced. So I would count how many I have in each one. So potassium, I have 1. Manganese, I have 1, and I have to break it apart. And oxygen, I have 4 of them. Okay, so I would look at my atomic mass for potassium, and that should be 39.10. Okay. Manganese should be 54.94. Be careful, don't mess it up for magnesium, they're different. And oxygen is 16. Do any multiplying I have. 4 times 16 is 64.00. And then I'm going to add all of this up. So 39.01 plus 54.94 plus 64.00. You're going to want to need your calculator for this one. Okay. And you should get 158.04 grams per mole. I don't want to write it in my head. That's the molar mass of potassium permanganate. So I'm going to do a couple more examples. This would be a good idea for where you'd want to maybe pause if you want to try one out. Often, of course, I'm not always going to give you the formula. I'm going to give you the name. And you have to put the name into formula, balance, and then calculate. Okay, so what does this look like? Let's do calcium phosphate. So calcium is Ca. Phosphate is PO4. Now, lovely enough, these are not balanced. Phosphate has a charge of 3 negative. Calcium has a charge of 2 positive. So that means I actually need 3 of these guys. And 2 of those guys. Okay, now it's balanced. Now we can actually calculate. Use a different color here. Okay, so calcium, I have 3 of them. Phosphorus, and this is where your understanding of how many there are in each one, careful. There are, right, that 2 is on the outside, so there's actually 2 phosphorus. Okay. And there are 8 oxygens. You have to break apart your polyatomic in order to calculate the molar mass. So we're going to look at calcium, and calcium should be 40.08. And phosphorus is 30.97. And oxygen is one that you become very familiar with, which is 16. So use this, don't do it in your head. Okay, so 3 times 40.08 equals 120.4. Oh, 24. And 2 times 30.97 should give you 61.94. And 8 times 16 should give you 128.00. Now we get to add these all up. Okay, so 120.24 plus 61.94 plus 128 gives you 310.18. And our units for molar mass, if you haven't picked this up yet, is grams per mole. Believe it or not, you don't actually have to memorize that unit. It's very, very tiny, but it actually tells you that right in the top part where it says atomic mass in brackets, it says grams per mole right there. Okay. So if we were to look at hydrogen, this one's actually a nice easy one. I should have enough room. Just be careful, right? We know hydrogen is not just H on its own. It's actually H2. So that means 2 times the atomic mass, which is 1.01, and hydrogen should be 2.02 grams per mole. Getting the hang of it, I hope. If you want to do these 2, you can pause, then replay, and try these guys out. These will be the last ones I'm going to do for this video, and then I'm going to give you guys some practice. So we have copper 1 sulfate, so just a little heads up reminder, that would mean that the copper is 1 positive, sulfate's 2 negative. Doesn't tell you how many there are of each one, that just tells you charges to balance. So copper, and that means I need 2 coppers, and sulfate is SO4. Now I have a balanced compound, which means I can calculate my molar mass. So 2 copper is 63.55, and sulfur should be 32.07. There's only 1 of them there. And oxygen is 4 of them times 16.00. Okay, I'm going to do my multiplying, and I should get Okay, copper bean 127.10. No multiplying for that one. And this should be 64. So add all of these guys up right there. Whew. And we should get wrong one. 223.17 grams per mole. Yeah? Last guy. We have calcium. Calcium is a charge of 2 positive. Acetate, reminder, if it doesn't look familiar, don't make it up. It's only polyatomics. Okay, acetate's a really big guy, looks weird. CH3COO. It has a charge of 1 negative. So that means I actually need 2 of these guys, which means in a polyatomic, I need to put brackets around them. Okay, so counting is key. I get 1 calcium. Carbon, so I have 1, 2 within the brackets, and then that 2 tells me to multiply everything inside of it by 2. So that means I have 4 carbons. Okay. 3 oxygens to start, because I have 2 polyatomics. I actually have 6 hydrogens, and 1, 2 oxygens times 2, I actually have 4 oxygens. Okay. Now find my atomic masses on my periodic table. Calcium should be 40.08. I know I don't have to multiply that one, so I'm just going to follow it through. Carbon should be 12.01. Yep, double checking that guy. Where's my example? There it is. Okay. 48.04. Make sure I don't make any silly mistakes by trying to do it in my head. Nitrogen is 1.01, so that should be 6.06. And carbon, that's oxygen, is 16.00, which should be 64. If I was to add all of these up, sorry, that one got a little crazy messy. 40.08 plus 48.04 plus 6.06 plus 64 equals 158.18. Put it over here for your total. Grams per mole for calcium acetate. Okay, I'm going to stop there, and we'll continue with this concept for calculations of moles and dealing with a formula that's actually at the back of the periodic table. Okay, have a good day, guys. Bye.